Hi, everyone. I hope you're all doing great. We are here for another weekly update and just going through Canvas here. You can see that, we've completed Unit 1 officially with, exam 1 that was due yesterday. Just a quick reminder that the final exam will be cumulative, so we will go back to this at the end. But I think this is actually a good thing, and I'll explain why. So also looking at your grade for the first exam, if you're not happy with your grade, the fact that the final exam is cumulative means that what I will do is I will look at your lower sort of those midterms that we are going to have after, so we'll have exams 1, 2, and 3 at the end of units 1, 2, 3. And then at the very end, we will have the final, which will also include the material from unit 4. And what I'm gonna do once we have all the grades in, I will take a look at exams 1, 2, and 3. I will take the lowest grade out of the 3, and I will compare that to your final exam. If you do better on the final exam, which is kind of your way to show that, you did master all of the content in the end. So if you do better on the final exam, I will replace your lowest midterm with that final exam score. What does that mean? Again, so this was our first exam. If you were not quite ready, that means that your final exam could replace this score. All right. If you're happy with it, then great. And, if you do, better on the final exam, then that could still be replacing it. Or, that also gives you a chance on the next 2 exams to, get a second chance if you don't do as well as you wished. So again, we're leaving our unit 1 behind, but just a reminder that the final will be cumulative. But now you've practiced a lot and you've taken your exam. So you have a good idea of what to expect to see also, on the final. There will be less questions on these first 3 chapters because it will be covering all of the other chapters, including, the unit 4 chapters, and we'll talk more about that when we get closer to that. But I just wanted to mention it now, just because, again, if you're not happy with how you did on exam 1, there's still a chance for that score to be replaced by your final exam score. I only do that for one of them. So, all right, if you want that to be the one that gets replaced, make sure to get a better score on exam 2 and 3. And if you're happy with your exam 1 score, congrats, and yeah, keep going. And yeah, you're doing great. So project part 1, also just a reminder that we have the first deadline coming up. I've seen groups, working on that. If, you've had a bit of, some issues communicating with your group, um, and you need a little bit more time, that would be okay. So just let me know. But remember that this is a group assignment, so please make sure that you talk with your group and that you all agree on what to submit, because you will have one submission for the group on all of the projects assignments. So those are all group assignments. Okay. All right. Now, if I keep going, we started working on Unit 2. And so what we have due tomorrow is chapter 3 on work and energy. And we're going to follow this chapter with chapter 4 this coming week and talk about impulse and momentum. So obviously this is in the physical sense of the term. Just real quick, you can see the assignments and the content is, the same as usual. I want to say we have the pre-chapter check, we have the lecture videos, the homework assignment, and here, this is going to be a quiz that's going to use a simulation like we've done before. I'm going to go over this information in a moment, but I just wanted to give you the overview first. Once again, you can see this is 0 points, so this is not mandatory, just for you to get a sense of what's coming. You can do, these in any order that you want. All right, so let's get started here. So impulse and momentum. So you have everything structured in the same way as usual, I want to say. And so we're going to start off with some definitions. In particular, we're looking at momentum. Here you can say that it says linear momentum because you'll see eventually in the next few weeks, we're going to be looking at rotational motion. So we're going to be applying all of these things that we're learning now to rotational motion. And at that point, we'll define something called angular momentum. So what you'll learn here, you'll actually repeat for rotations. But if you understand what's going on for linear motion, or what we also call translational motion, you will see that it essentially translates very well to rotational motion. We're going to see that, so momentum typically is something that is calculated based on the mass of the object that we're studying. So again, mass represents um, the inertia of the object. And for the momentum, in addition to mass, we will need the velocity. So we'll see that momentum is a vector, and sometimes we call it inertia in motion. But we will see why we need this quantity, why it's important. In particular, we'll see that there is a relationship between momentum and a force. We've talked about forces when we talked about Newton's laws of motion, and we're going to see that we can actually restate Newton's second law using momentum. And so with that, we'll see also the definition of impulse, and but that depends on the definition of momentum. And we will see that just like energy, momentum is something that can be conserved again, given the right conditions, and that's going to be very helpful in terms of particular applications that will show up specifically for what we'll call collisions. Collisions will define different types of collisions. And we'll see that. So usually when you hear the word collision, if it's in a physics problem, that should make you think conservation of momentum. So whenever we have something with collision, so it could be, I don't know what you picture when you think of a collision, maybe, a car accident, but it could be if you play like billiard or like but in the concept of collisions, one of their reflex should be to think about using conservation of momentum, and we'll see how that works in this chapter. All right, so you have your sort of original or usual, I should say, videos. Here you can see the impulse explained. So these are very nice illustrations of the concept. So I would highly recommend those videos. We're gonna skip over the pre-chapter check and then go to the content just to show you where things are at. So again, just going over the definitions and essentially seeing how we're going to apply our concepts. We're gonna see that there's some examples here to show you exactly how you can apply conservation of momentum to particular situations. Then we have homework that you have to complete and a quiz. But so this quiz again is one of those that's going to use a simulation. So it's similar to what we did with projectile motion. And you can use either one. So I would, explore both of them. I have them both here. I will show you in a minute. They do the same thing, so you can pick the one that's easier for you to use. Also, whenever we use simulations, I would say this could be a good companion for when you're doing homework or when you're watching videos, lecture videos, and you would like to, actually see what you're learning in action. So this is the O physics simulation, and so it's a little bit busy, but you can see that we are looking at two objects here. They're moving on the ground here, so they're going to move on a flat surface. We have this red cube and this blue cube, and we can set up collisions in different ways. What you'll see is that right now we're showing something called the center of mass. So this is interesting, but if it's adding something extra information, you can remove that. But if you're wondering what this is for center of mass. It's showing a number of information like energy, so initial kinetic energy, initial momentum. So it's a bit weird, but momentum is usually represented by the letter P. This is historical. And here for the other object, same thing, initial kinetic energy and momentum. You can see that momentum is in fact a vector. So you'll see that it has a direction. So for red here, it's positive. For blue, it is negative. I mentioned that collisions could be, so we saw there's elastic and inelastic collisions. Really quick, essentially, for elastic collisions, kinetic energy is conserved. That's sort of an ideal case. Most of the collisions that we consider in real life are inelastic, and kinetic energy is not conserved because like there's sound and other things where that energy is actually not going to be conserved in the process. So here you have this coefficient that can go between 0 and 1. So if you go to 0, you can see we have something totally inelastic, which is the most extreme case. And that's when the two objects are going to stick together after collision. We can see an example. So we can run this and see. You can see they stick together after the collision. Then I can reset, and then we can do the exact opposite, perfectly elastic. And then we can see the difference, and you see they bounce off each other. So there's a number of things that you can change. You can change the initial velocity of either one of your boxes. You can change the masses. So for example, we would want to check what happens if we have the same mass. I believe you can also enter the number instead of if you know that you want to go to 3. For example, We can run that. We can give them, sometimes we like to have one object that is at rest. So I could say, all right, so my blue one is gonna start from rest. That would mean that I give it an initial velocity of 0, and I could run that and see what happens. So in the questions in the quiz, it will ask you, to set up different scenarios and essentially watch what happens. So again, things that you may need, right, would be the initial conditions for velocities for either of the objects, the masses of the objects, and you can see also over here whether you're considering, what kind of collision are you considering. This one also shows you, as you saw, the velocity of the objects, their momentum. So as you're learning about the momentum and what it means, you'll see that it's going to really relate, right, to um, the velocities. And you can also see that we have this is the sum of the momenta. So this is a total for your system. And I would also watch that because we just mentioned that that should be something that is conserved. All right. So that is for this one. You can also use the PHYS simulation. There's the intro. You can also explore. So we're going to stick with 1D, but if you wanted to also explore 2D, instead of having everything on a flat ground, that would, for example, when you're looking at just more general questions or homework questions. But otherwise, if I do explore 1D, you can see that this is looking somewhat similar. We can show the velocities in green here. We could show the momenta of my objects. You can see the difference, and that's because they have different masses. So the mass is going to influence the value of the momentum. You can change, right, the masses, so I could match them so they have the same mass. We can see more data, so the positions, you could change these numbers as well, and that will give you sort of the similar situations to what you saw in the previous simulation. Same thing here. You can see we have fully, perfectly elastic or completely inelastic or somewhere in the middle. And as we do that, now for this one, the way you would run it is like this. You see, in this case, I said completely inelastic, so they stick together after the collision. You can also see the value of kinetic energy, the velocities. You could also show the center of mass for this one. But otherwise, you can see it's fairly similar to what we saw in the previous one. So that's it for this chapter. Once we keep going, you see that we go to the next one, which will be oscillations and wave that we'll talk about next, the following week. All right. So again, if you have any questions, please don't hesitate to reach out. Have a wonderful week. Thank you so much.